Welcome to this fourth subunit on Open Analysis from the Open Education Science unit. The objective of Open Analysis is to make the reproduction of the analytics that you have conducted in your research study much easier by other researchers. This makes very easy for other researchers to conduct independent reproduction studies, which are helpful, for example, to find mistakes and errors in your methods. This also enables an easy replication so that other researchers can use your methods in a very similar research study to replicate your findings or to find that your findings don't replicate in another context. And it can also use just to take your analytical methods from your study into something completely different, but reusing this kind of code and procedure. Additionally, this process plays very well with code tracking tools at platforms like GitHub or SVN, so that you can take a truthful account of the history of changes in the code, representing how your analysis change over time. There are a number of research tools out there that we can use, most of them to perform quantitative analysis, but there are important factors that we should take into account. First one is if we have proprietary or free software. One question that you should do yourself is if you generate your research with proprietary software, if the reproduction will be available to everyone. Then is the use of interoperable data formats so that other researchers can take your data and put that into their systems without any issue. Then we have programming versus point-and-click interfaces. Programming environments always will facilitate reproduction of a method more easily than point-and-click interface because you cannot capture the procedure the same way every time that you do it. There might be human errors that are hard to spot. And then you should consider also a flexible library system, and if there are an active community out there that could also use your methods. The recommendation is a bit personal from me, coming from me, but it's general also from many members of the community, is that the most standard options for reproducible research are using R and Python programming languages. Additionally, it's very useful to use Docker or Ansible containers so that you can provide a way for other researchers to replicate exactly the same environment where your research was conducted, so that we avoid problems between versions and so on. Then we also have a number of ethical discussions regarding which kind of tools we use based on these factors, and if the proprietary software is going to be relevant in the future. I put these links so that you can check them afterwards. I think they're interesting reads. And I also added a link of a very nice, interesting video of why it's important to conduct reproducible research. Please check them out after you finish this presentation. So my personal recommendation is to use Jupyter notebooks and R Markdown to provide your open analysis in the web. The reason is because they provide a very easy way to combine narrative, code, and output, so that in the same environment you can do all these things. They are also very easily exportable and hosted in different formats like HTML, which is easy for posting things on the web, and they use Markdown syntax for the design of the document. So Jupyter notebooks were originally part of a Python environment, but now they support also to execute other code like R and other programming languages. There is more information in their webpage, which is jupyter.org. And if you install the Anaconda distribution for Python, it automatically comes with Jupyter, so it's very convenient. I have here the same example of the notebook that I posted, that I talk about during the first subunit, and I also put this here, which is a gallery of interesting examples using Jupyter notebooks to share research and methods. So please come here and check some of these very interesting examples so that you have an idea of how you could translate your methods in your research to these kind of notebooks. The other option is using R Markdown, which automatically comes integrated with R Studio, which most people use for conducting R programming. It's compiled with a package which is called knitr, which can compile the R Markdown file into an output which can be HTML or PDF. So it's, again, very convenient to share these two formats, which, as we said, it's important they should be interoperable. I put here links for the R Markdown tutorial and the R Markdown cheat sheet. And again, I put here this gallery that put examples of reports generated with R Markdown and with Shiny, which is another one of the environments that comes with RStudio. Again, check them out so that you can take some ideas of how to make your research more interactive and accessible. This is an example of the Jupyter interface, and as you see, we can combine titles, narrative, code, and after the code, we see the output that this code generated. So this way we combine the three things, and it's much easy to read your research and understand your methods. This is the example of the R Markdown interface, and it's, again, very similar. We have here code, we have narrative, we have code, and then one is compiled, and we see on the right side the code also displays the output of this code. So that, again, we are combining narrative with code with the output that generated your code. So as conclusions, if we join together open designs and open data, then we are this enables the implementation of open analysis that is the full reproducibility of the research cycle, and then it's completely transparent to the researcher what you've done during your research. Most of these formats allow for HTML outputs that can combine the code and the results of your research, and then they are very interoperable and easily hosted on the web. So that's a very important feature. Some advice: code is only as good if it can be understood and replicated, so that once you are preparing your open analysis, you should take into account to write readable code, avoid obfuscation of things that are very hard to read. You should write comments explaining your decisions, and very important, don't perform any manual change outside the code, because then the full replication cycle is broken and people don't understand what happened, what is missing there. In the future, we could envision that the future of research papers will look much more like we've seen here, because we can combine narrative and code and output. This could be an interactive paper where we are combining all the description, but people still could read what is the code that you're reading and the output of each part of the code. And even, perhaps, if it's a nice environment, people could change the code so that they see other things from the data in the future. With some examples of quantitative research, but this process of more transparent data analysis can also be applied to qualitative research, for example, by sharing coding schemes, the coded or disagreement examples, and so on. Again, it's always about being more transparent about the analysis that you have conducted. And one last piece of advice is to follow guidelines that explain how to share these analyses so that other people can access them. And these are two examples of the protocols and principles. These are the references that I use. I hope that you enjoyed this unit. Again, remember that you have an exercise to finish. And in next subunit, we'll finish the last step of the process. See you there.